was waiting for you people to tell me when to start.
Okay.
I'm all set. Yes.
Yes. Thanks.
Okay,
Good evening,
so
everyone.
let's start. Let me. Yes. Right.
Yes, sir.
Go ahead, please.
Okay. Thank you,
Go
sir.
ahead. Yes. Go ahead.
Good evening, everyone. It's wonderful to have you back as we continue our FDP on challenges of autonomous and electric vehicle. Thank you for joining and your active participation so far. Today's
अच्छा
third
बोलती
lesson
है
will be on the topic of sensor
कृति है
and
ये
AI
नवदेव सिंह के अंडर में पीएचडी
mode
की है
for control of autonomous car and will be delivered by
माइक वाइक
Dr.
में
Rahul
लिखे
Dubey.
मेरा
Dr. Rahul Dubey is a member of technical staff at a global training solution company and it is based in San Francisco Bay Area, USA. He possesses a mix of academic and industrial experiences. He started his career as application engineer for energy automation and participated in the design of control systems for various industries such as textile, tires, petrochemical, cement, and automotive test stands. Subsequently, for a decade and a half, he was a faculty member at a multiple university and taught courses on industrial automation, embedded system, and digital design. Please welcome Dr. Rahul Dubey, sir. Over to you, sir.
Thank you very much. Thank you very much, Anukriti.
Thank you, sir.
Yeah, so the first thing that you must have noticed that I am the same person that you see on the picture. It is, so you have to take me for granted. I'm the same person. Okay, let me share
Yes.
my screen and
Yes, sir.
we'll
You
get
can-
started. Let me share my screen. Okay, so tell me whether you see the screen of mine. Anukriti, do you?
Right now.
Do you not yet?
No, sir. We
Are you able
No,
to
sir.
do-
are not.
Not yet?
We are not
please
able to see. Yeah.
You're not able to
Yes.
see. Let me check again. Okay, let me see. Okay, share content. There you go. Window. Entire screen. Okay, see. Window. Okay, sure. Okay, now tell me again, can you see my screen now?
Yes. It
Now
is good.
visible.
Yeah.
You can now see
Visible,
my
sir.
screen? You can, yes?
Yes.
Okay, so I assume that you can see. Okay, very good. Okay, so welcome to this, let's see, should I keep my face on? Maybe, yeah, why not? Okay, so welcome to this session on sensors and AI models for control of autonomous cars.
Sorry to interrupt you, sir, but PPT is not visible.
It is visible now? Okay, let me see, stop sharing. Okay, let's see where this is this thing. Let me turn off my camera. Maybe it's let's share again. Share. Tab window. Okay, let's see at this window. Can you see my oh. Okay, slide now or not? Oh, here. Okay. Okay. So what am I sharing right now?
It's showing a white screen, sir.
It's white screen. Okay, so
Yes.
to hear me when I was talking?
Yeah, sir. We can hear you.
Entire screen. You can hear me, so please tell me, otherwise I will be flying dark. Can you see my screen now?
No,
Yeah,
just
the
audio
screen is-
audible.
Can you see my screen? Can you see my screen? My slide, I should say.
Yes.
No,
Slide
sir, we are
is-
not able to see.
No, sir, not able to see your slide. Even the voice is
That is why
also
I'm,
not coming properly.
my voice is also not coming properly. Is it coming properly now?
Yeah, it's coming
Yes, now coming
properly.
properly. Sometimes it is breaking.
Now it's coming properly. It's breaking.
Yes.
Okay, maybe it's an. So now
That's a technical
put
issue.
my.
It's a
So is it
network
coming
issue.
better now?
Yes, sir.
Possibly network. Is it coming better now? Okay. Hopefully it should
Yeah,
continue
yes,
this
Yes.
way.
Okay.
Okay, now it's better. Okay, let's get this thing working. Let's hopefully say entire screen. Okay, share. Okay.
Yeah, screen
so
is visible,
can you
sir.
see my screen? Can you
Yeah,
see my
and the
slide
PPT is
now?
visible. Yes. yes,
PPT
sir.
is visible. Can you see my slide in full presentation mode?
Yes. Now
Yes.
visible your sensors and light.
Yes, sir.
Yes.
Yes.
Very good, Chalo. It did take some time, but all is well
Yes,
that
sir.
ends well. So we have reached our,
Yeah, okay.
at least one destination we have reached. Okay, so welcome to
proceed,
this
sir.
training. Welcome to this discussion, I should not say training, discussion on sensors and AI models for control of autonomous cars. These are two very important components. Okay, without these two components, it would not have been possible to create autonomous cars because electric cars were there for a long time. Okay, because we always had electric motors, we could have made large batteries to power these electric motors, but it is these two components, the sensors and computer vision AI models, that have made autonomous cars feasible these days. Okay, so we'll talk about some concepts, some design flow, and we will end with real world examples. Let's look at this. So what are autonomous cars? Basically, autonomous cars are basically systems, are AI systems that work at network edge. So they basically do the entire control loop. Control loop means sensing, feedback, and also control of the car. And most autonomous cars, they started out with this system called as ADAS. So ADAS stands for Advanced Driver Assistance Systems. So let me discuss with you what are some of the components of ADAS. Some components are that if you're trying to take a turn and there is a car in your blind spot, the sensor will check there is a car in your blind spot, and it will tell you that there is a car in the blind spot. Do not take or do not change lanes. ADAS also allows you to look at the lane markings and follow the lane markings. So these are very simple systems, and they were the first step. They were the first step towards creating autonomous vehicles, was creating ADAS. And most cars today have some kind of an ADAS system available. If you get very close to a person, it may then apply the brakes. If it comes very close to another car, it can also apply brakes. So these are simple systems, and these simple systems is what it started, and they were the foundation for creating autonomous cars. Now all the technology that is developed for autonomous cars, that technology can also be reused into many other applications. It's not just cars. It could be also autonomous trucks. It could be autonomous tractors. It could be autonomous. Many things can be made autonomous on the road, or on the mines also. You can have autonomous mining machines, so that you don't have to have a person sitting on top of those machines because the mining environment is not very good. Okay, so this is a brief overview about the start of this particular technology, and where it's going to lead us to. Okay, so what are the commonly used AI models? So there is a simple model which is used very frequently on autonomous cars, and it is called as a convolutional neural network. And what it does basically, it is what helps you to look at images. These days, autonomous cars have close to 25 cameras mounted along the entire body of the car. And these cameras, they're always sensing, they're always looking at things around them. And these images are basically analyzed by the convolutional neural network, which can do image classification, which can do object detection, and which can do object segmentation. So these are the three categories of things that you can achieve using convolutional neural network. And these are widely used inside autonomous cars. And these neural networks can also be used for the ADAS systems. So ADAS system means they can be trained to recognize people. So as soon as a human being comes in front of the car, it will beep, it will give you an alarm. And these days, the most important, the very beautiful thing about this, about ADAS system, is that if you're going on a long drive, okay, you're going on a long drive. Let us say you're driving from Gorakhpur to Noida on the expressway, and when you drive from Gorakhpur to Noida, you may feel drowsy or sleepy. So there is a small camera which can see your eyelids. And if you appear to be drowsy and your eyelids are closing, the car will beep and say that, please stop, have a cup of tea or coffee, and then resume your journey. So this is a very simple safety mechanism which is made possible by these simple computer vision models, which are based on the convolutional neural networks. Okay, so these are very simple things, and they are part of ADAS. So what I have just described to you earlier was a driver drowsiness detector, which uses a computer vision model based on the convolutional neural network. So where are these models trained, and how are these models used? So the model training is carried out on a GPU-based computer, but the training is not on the edge. It is done at some central location. So once you have a trained model, once the model has been trained to recognize human beings, or the model is trained to recognize drowsy eyes, it is then transferred to a small computer which runs inside the car. Okay, and then so this well-trained model can work with multiple people. It does not matter whether a person whether the person is male or female. They have been trained across a big data set, and they can generalize very nicely. And I have seen this because once I was driving and I saw that I was feeling drowsy, and then I realized when the car's dashboard said that you should take a stop or you should take some rest and then drive. So that is something I have experienced firsthand. That is very useful, and it is a good safety feature. Okay, so all models are trained in this manner. They are trained outside, and then the trained model is run on a small computer inside the car. Okay. Now, what are the components of autonomous cars? So I'm sure that you guys know about control systems. And the control system, it is the same kind of control loop that is also inside an autonomous car. There is a sensor. Those sensors can be of several kinds. You can have a camera, you can have a LiDAR, you can have a radar. Different kinds of sensors are mounted on the car. A lot of instrumentation is done because you don't, suppose I blindfold you. Blindfold means that I basically cover your eyes and I ask you to walk. So you will need all kinds of assistance that you can get so that you can follow a path. So the same thing is, so you have to have lots of sensors. So for our human body, the sensors are the eyes, ears, so we can see, if there is a sound behind us, we will know something, some vehicle is coming, we will become alert. So the same idea is, the more sensors you have, the more you can be very sure that you are moving in the right direction. So you can make deterministic judgment if you have more sensors. So all the contemporary autonomous cars have a variety of sensors, and we'll talk about them shortly. So inside the control loop, you have a controller, and the controller is based on an AI model. So the job of the controller, which does the path planning, it can be based on an AI model, and then you have an actuator. So the actuator's job is to take action. So the case of the actuator is to control the steering wheel, or control the gas pedal, or to control the accelerator or the brake. This is the actuator. So it's a control loop, and this control loop is basically based on the same fundamentals of control theory that I think all of you are acquainted with. There is also communication happening. There is a non-real-time communication happening between the car and some kind of a centralized database, because this communication mechanism is used to gather more data so that the better models can be trained, such that we can create, suppose the car sees some object which it has not seen before, it will then communicate that object back to the central repository, and a brand new model will get trained, and that brand new model will get deployed to the new cars. So this is a communication mechanism. This does not control the car. This is just to find out if there is anything new that needs to be reported back so that it can be used for the next round of training. Okay, any questions or comments so far? Okay, let us continue. We will have question and answer session at the end then. Okay, so this is, if you see this slide, it looks very dense. Okay, there's lots of information on the slide, but let us try to understand what is on the slide. Okay, so you see that, let's say this is the car. Now these are, let's say on the top, you see on the top, there are these many cameras. There are so many cameras. So there are more than 40 sensors on the car. So you have like a rear camera, you have a side rear camera, you have a forward side, wide forward. So there are so many cameras, and all these cameras are feeding in a video stream to the AI controller, and the AI controller is trying to basically determine if the car can move safely ahead. If there is no obstruction, no obstacle, all these cameras will work together to jointly make a decision. Okay, and as I said earlier, there are some sensors here which can see if there are any cars in the blind spot. So when you're trying to change lanes, you should always look over your shoulder to make sure there are no cars in the blind spot. And there are cameras which can sense any cars in the blind spot, so they will basically alert you when you change lanes. Now, there are also radars. So these are basically radars which we can have a long-range radar, a medium-range radar, a short-range radar. Now these all radars, they basically supplement what the camera sees. Suppose it's a foggy day, okay, and you have a lot of fog, and the camera cannot see much. So this is where radars become very useful, because cameras cannot see beyond a certain distance. That is why radars and lidars can become useful, because they can work in different weather conditions. Okay, so there are all these things that can be useful. It can be used for acceleration, deceleration, lane change, collision avoidance. All these basically all this functionality is basically enabled by the use of these sensors. Something called as cruise mode. So cruise mode, I'm not sure whether you guys have used it or not. Let me describe it. Cruise mode is, again, when you're on a long journey and you don't want to put your foot on the accelerator all the time, you can set a speed and you can set a distance, a safe following distance from the car in front of you. And the car will use these sensors to maintain that safe distance. And as the car in front slows down, your car will also slow down because it knows that what is the safe distance to follow. So that is again based on cameras, or it can be based on these kinds of radars. So as you see here, what are these sensors used for? So if you have sensors, so first of all, the sensors, they help with better perception. And if you add more sensors, they help with basically ADAS, which we talked about earlier. You add more sensors that will help you to basically achieve autonomy. This is the role of sensors. And sensors are expensive, okay? And that is why autonomous cars, they can be expensive at times. There is a company, you may have heard about its name, Tesla. Tesla believes that it does not need radars or LiDARs. It thinks that cameras can work fine. So it just uses cameras. But basically other car companies such as Waymo, Waymo uses lots of cameras and lots of LiDARs and radars. It basically has instrumented the whole car, so it's very safe. So adding sensors is not trivial, and it can make the car more expensive. So these days, the cars from Waymo are not sold in public. They're just used as taxis because it is going to be very expensive to sell that car. Okay, let's move further. This is another view of sensors and connectivity. Again, you have tons of sensors, very similar to the previous slide. The important thing to understand is these cameras, they provide a 360-degree view. Okay, so these cars, believe it or not, in some time, they will end up being more safer. They will drive safer than human beings because they have a 360-degree view of the entire surrounding. And when we drive a car, we just don't look everywhere. We just look in the front. So we don't have a 360-degree view. So this is going to lead to safety also because of this aspect. Okay. And there are, as I said, there are numerous options. You can have collision avoidance systems. You can have pedestrian detection, so you don't hurt people trying to cross the road. Okay, you have these long range, radar, very useful. Okay, so let's move further. So how does it work? How does all the components that we discussed, how does it all fall in place? So what we have is that these sensors on the top of the car, so there could be a LiDAR on the top, there could be cameras, they all feed or they get information which can calculate the depth, which can see the visual image, is fed. So there are multiple sensors. That is why it's called as multimodal. Okay, it's not only looking at cameras, it's looking at many other sensors. So it's a multimodal model. And then it is used to generate these navigational commands. And this deep neural network, or this AI model, is then used to control the steering wheel, control the speed, and there is a PID controller which controls the brake and controls the accelerator. This is an end-to-end system explaining how sensors and AI models work in an autonomous car. Okay, so this is based on this reference which I have shown at the end. Okay. So what are the brains inside the autonomous car? What is the controller? Okay, so there could be a controller. So the car can have multiple controllers. This is where there is a domain controller which can look at connectivity. There could be a domain controller which is looking at the drivetrain, which is the shaft, which is the wheels. There is a controller looking for body and comfort, which is the air conditioning systems, the power windows. There could be a controller which could be looking at ADAS kind of activity. There could be another domain controller which could be looking at infotainment. If you want to run some audio, video, something on your screen, it is. So there are these multiple controllers, these multiple domain controllers, and they are all segregated. It is not keeping all the eggs in one basket. You have these different roles. They have been assigned to each of these domain controllers. Okay, so these are two basic systems. So that there is one, or in this case, they can all feed in information. So this is a distributed control system. This is a centralized control system on the right-hand side. So on this centralized control system, you have these gateways, and they all feed in information to a central system, and that central systems will do all the decision making based on the inputs from these different zonal gateways. Okay. So as you see, as I mentioned to you earlier, that we as humans also do sensor fusion. See, we have our eyes looking for images. We have ears looking for sound. We have nose, which can also detect smell. We have the skin, which can detect hot or cold temperature. So there is a fusion of the information obtained from various sensors, and there is sensor fusion has become a very big field. That how do you assimilate information from all these different sensors, and this raw sensor data is then fed to the central compute, electronic control unit of the car. And this is where you use your different models to process the information from different sensors. Now, what kind of control systems are inside? So inside the car, you have these. You can have a PID controller, which you guys must have read in the control theory, which does the control of the steering wheel, accelerator, and brake. Then you have these real-time control loops. So these control loops have to be real-time, like most control loops, because when you're driving the car, you have to make instantaneous decisions. When you're trying to change lanes or you're trying to follow something, you have to be able to make instantaneous decisions. That is why you have these control loops. And there have been reports where an autonomous car has braked. So what happens is, suppose there is a lane which has a blind spot that somebody runs across. Okay, somebody runs across the road. But this car could sense that somebody is coming and it stopped. Had it been a human driver, it would not have been able to anticipate that somebody is going to cross the road. Okay. Is there any question? Somebody is trying to ask a question, or I just felt that way? Okay, fine. Okay, and then what are different kinds of controllers that we use? We could use simple CPUs, central processing units. These days, GPUs have become very popular. So these days, these two are the hardware which is placed inside the autonomous car, and they are able to do the AI model inferencing. There is also FPGAs, which can work very quickly. They could also be used for the task of digital controller, or you could have custom chips, custom AI chips, which can basically do neural network inference acceleration. These are different options which are used by different companies. So the process of making an AI model is not very simple. I mean, it is simple, but it is very tedious. It takes a lot of effort. So how do you create an AI model? So you have to use clean, pre-processed data for training. Okay, and if you have large data sets, you can weed out noise. So if you have a large data set, it is going to basically take out any kind of discrepancies, any kind of noise. So it is good to do that. And also, you could also experiment with features. So what does features mean? Feature means, what do you want to sense? What sensor is the best? You want to use 10 cameras or 20 cameras? Or why not 200 cameras? So you have to then determine what is the optimum number of cameras, because each camera is giving you a feature. And that feature is helping you to build a better model. So you have to experimentally determine, while also monitoring accuracy, what is the best sweet spot for the number of sensors. You don't want to over-engineer your system. You don't want to have 200 cameras. Maybe you think that 5 cameras are the best ones as the best optimized value. Also, you have to keep an eye on the performance metric. That is it working correctly in different scenarios? Okay. So this is where you have to make sure that for creating AI models, you have to have good data, because that good data is going to lead to a good model. If you don't have good data, you will not get a good model. So in terms of an analogy, if you don't have a good textbook or you don't have a good teacher, you will not learn much. So the teacher or a textbook is the data set, because the AI model learns from the data. So if you give it data which is not representative of the actual scenario, it will not learn much. So you can train the best model in the world, but if you feed it data which is not good, that model cannot learn anything. Okay, that is why data collection and preparation is very important. And most of these companies, they have a big team of people which is basically doing data collection and data preparation. Okay. So many times you have to use transfer learning. You don't want to really create a new model architecture every time. So what you do is you use transfer learning, is where you basically leverage existing pre-trained models. You don't want to recreate the wheel every time. So using existing pre-trained models helps you to work with small data sets, and you could very easily reuse models. So you don't have to create it from scratch. And transfer learning has become a very frequently used way to create a new model, which is not creating it from scratch, but by using something existing and then fine-tuning it to your application. That is the idea of transfer learning. So there are multiple model metrics that you can achieve, that you can test your models, to something called as the mean average precision, the F1 score, and you have to set some kind of realistic metric for your application. Suppose you want to make sure that your model can detect human beings all the time. So you have to feed your model different types of humans. It could be a child, it could be a lady, it could be a man. You could even feed your model if it doesn't want to collide with animals. You can even feed images of different animals which it can likely encounter. Okay. And then you have to quantize the model, because the computer in the car is small. Okay, it's not possible to keep a server inside the car. So you have to keep a small computer inside the car, which will execute the model and execute the control loop. So you have to quantize the model such that you have to convert the weights and biases from a 32-bit floating point value to an 8-bit so that it consumes lower power, it consumes lower memory, okay? And quantization, we have seen, does not adversely affect the accuracy of the model. So once your model has been prepared, once your model has learned to take in the sensors and to move the car based on what the sensors are asking it to do, so you have to execute the model graph. So this is what is being done inside the car. These are the steps being followed inside the car. So it gets the inputs from the sensors. So inside an AI model, the sensor input, suppose there's a camera. So the camera input goes as the input tensor. That input tensor is then presented to the model for inference, and the output value from the model will then tell whether there is a person in front or what has to be done. If there is a clear road, then the car's computer will then tell the car to drive forward. If there is an obstacle, it will tell it to stop, and so on and so forth. So this is all done inside the car's computer is processed. So this is the typical loop which is going to be done all the time. This is an infinite loop which keeps on executing all the time. Okay. There are many APIs. Suppose there are these different model formats, and they are used to capture the model architecture. And they have this Python or C++ APIs, and they are basically used to run the model stored in these different formats. Let's take a look at some brief real-world examples. So I would recommend you can go to the website of these things which I have mentioned here. You can make a note something. This is the website of Tesla, Autopilot. So Tesla just uses cameras. So you have multiple cameras. You have a forward, you have like a rearward looking side camera. You have wide forward camera. So it just basically uses cameras. And this is why it is very cost effective. It does not use many other LiDARs or radars. This is the thing from Waymo. So Waymo is a car company. It is an offshoot of Google. So you see, it basically uses LiDAR. The LiDAR is something that you see on top of the car. This is the LiDAR on top. It basically creates a 3D map of the surrounding. It can very accurately map the surrounding using LiDAR. And this is a very powerful sensor. So LiDAR is one of the most important sensors which has made autonomous cars feasible. Okay, there is a big debate where Elon Musk said the companies that use LiDARs are fools because cameras are going to be sufficient. But what we have seen that LiDARs are the ones that give you a real picture, the real 3D perception, which a camera may not give. Okay, so since LiDARs are expensive, they're not used frequently. You have LiDARs and you also have cameras. So you can see the camera. So the cameras are doing object detection here. So this camera is now seeing people. The camera is seeing cars. The camera is seeing these parked scooters. This is all being done by the camera. And the information from the camera is validated by the LiDAR. So there are two sensors working together, and they both help each other. So just to be doubly sure, so these sensors, they make sure, they basically cross-check what the other sensor is saying. And this process of cross-checking makes it safer. Okay, because if you just rely on one sensor, it may be seeing something wrong, or there could be some kind of error. But this process of cross-checking makes it safer. Let's move further. There is the third sensor, which is the radar. So radar is also used, and it works when you have snow, you have fog. At those times, radar can become very useful. And inside the car, it is at the back that you have all the computers that are going to basically control or that are going to run the AI model. They're all located in the back portion of the car, and they are basically wired to all the sensors, and they are going to execute the control loop. They are the ones which are going to control the steering wheel, the ones they are going to be controlling the brakes. So when I go to San Francisco many times, I have not taken a ride in any of these autonomous cars as yet, but I see many of these autonomous cars working very smoothly. So I've seen them, and then now nobody even takes a second look at them. They have become so common that you see the cars, you can call them just like Ola or in Uber. They will come to you. You can sit inside. They will take you to your destination. There is no driver, and they have literally mastered it now. And this mastering has come about with the help of these different kinds of sensors. Cameras, LiDAR, radar. So I would recommend you please go to this website, which is waymo.com, Waymo-driver. So all this information, there is a beautiful video on that website. I would highly encourage you guys to watch it. Okay, so dealing with Murphy's Law. So Murphy's Law says that anything that can go wrong will go wrong. So when you're driving a car, when you're driving an autonomous car, and there are real people inside the car, you don't want anything to go wrong. Okay, you don't want the people to get locked inside the car. Okay, you don't want the car to be hacked by somebody else. You don't want the power to fail. Okay, so that the car starts to misbehave. In fact, there was a recent happening that in Los Angeles, a person booked an autonomous car to go to the airport, and instead of going to the airport, the car started driving itself in circles, and the person had no way to stop this behavior. He was at the mercy of the car. Okay, so you have to have a mechanism to deal with when things go wrong. And Murphy's Law says that anything that can go wrong will go wrong. Okay, that is Murphy's Law. So what are the safety considerations that these companies put? So let us think about this. Like inside Waymo, this information that I put on the slide again is from the Waymo.com website. So there is redundant braking. Okay, there is a secondary compute. So if the main computer fails or stops to respond, there is a secondary compute which will take over. There is a backup power system. There is a backup collision detection and avoidance system. There is a backup measurement systems for the vehicle positioning. You have a redundant steering that if somehow it fails. And there is a huge cybersecurity, such that anybody cannot take control of the car and drive it someplace else. So you see that even though the main system is quite strong and quite robust, despite that, you have to make a second layer such that if it does not work the way you have designed it to be, it should be fail-safe. Okay, and these are some ways that you can make it fail-safe. What you see on your screens. Okay, so there is a company that a lot of you may have heard by the name NVIDIA. So NVIDIA is not a car company. This is a company which makes GPUs, which makes these GPUs which are used for training And it also makes GPUs which are put inside these autonomous cars. So what NVIDIA does, it does this. It says, well, there may be car companies which do not have the engineering manpower resources to create AI models or to create so many basic foundational technology. So they have created the system where they basically give you all the tools. They will help you integrate the sensors. They will help you run the model. They will give you GPUs, and it all runs on a Linux-based system. And there is also an RTOS. So there is an RTOS, like there is a real-time operating system, and that real-time operating system is the one that controls the steering wheel, the brake, and the accelerator. So basically, NVIDIA says any company which does not have the skills, they can come to us, and we will sell them this technology because they have to buy NVIDIA's GPUs and all other things. So many companies throughout the world, such as Mercedes and I think Toyota, they have opted for using NVIDIA's technology that you see on the screen, such that they don't have to create it from scratch. Okay, so they have this direct access to imaging sensors and hardware accelerators. So it is all built in. It is all basically prepackaged. Okay. So certain car companies, they may not have to employ thousands of AI people. They can go to NVIDIA and buy it from them, and NVIDIA will sell it to them, because if they buy it, they will have NVIDIA will sell its GPUs in the process. So there is a win-win for both companies. So you can extend all the concepts that we have discussed so far, the sensors, the actuator, the controller. You can extend the application of this autonomous technology. You can extend it to precision agriculture. You can extend it to creating these farm machines. So US has huge farms, thousands of acres per farmer. So here, if you see here, this is the LiDAR on the front, and if you see, these are all cameras on the top. So on the top you see all cameras, and on the front is a LiDAR, and you can see the tractor has been instrumented. And all these sensors have been put on it so that it can autonomously do the work on the farm by itself. So if you see here, it says it has a 360-degree view camera. It has a high-speed processor, which can process video stream from multiple cameras in real time, and it works with these neural networks. And its update rate of the control loop is around 100 milliseconds. So every 100 millisecond, the control loop updates itself. So that means it is working real fast. Suppose you're driving a car, let us say 100 kilometers per hour. So if the control loop takes a long time to update, the car will not be responsive in that small interval of the update time. So this, that is why the control loop has to update itself very quickly. And for a tractor, this is a very simple application, because in the field you won't have people. It goes slowly. This is a very simple, benign application as compared to driving on a freeway and driving in an autonomous mode. But the same technology can be extended for many other applications.
Hello? Hello, sir. Are you audible? I'm audible up to you? Your voice is not coming, sir. Hello, Rahul, sir. Hello. Hello, sir. I think your hello. Hello, Rahul, sir. Your audio is not coming. Hello. Hello. Sir, you are muted, I think. Hello, sir. Please unmute your mic. Hello. Hello, sir. Is some hissing sound is coming out from your side? Hello, sir. Hello, Rahul, sir. I'm audible to you.
Anukriti is busy. Some call is coming from.
Okay, sir. Okay, sir.
Goodness. Can you guys hear me or not?
Yes, sir. Right now I can hear you.
You can hear me? Okay, very good. Okay, tell me, any questions?
Yes, a participant, you can ask a question.
Yes, you can type in your question and I'll basically read it from chat.
Yes, sir. One question is on the chat box, sir.
Yes, I think that question is you can get it from open source or you have to collect your own data. There is an ImageNet data set or there's a COCO data set which you can use for model training. But that's a very simple open source data set. But for more expansive data set, the companies collect their own data. Because you may not have, but there is something important. You can go to Waymo's website, okay, Waymo, and Waymo has put a lot of its data set that it has collected while its own process of testing the car. They have put their own data set which could be useful. So you can get data set from Waymo's website. It is open source. That is one option. Okay. So you want to do is check, let me see. Okay, Waymo data set. Okay. So I will put the link to the data set on the chat. Okay, this is the link to the data set. Okay. Okay, there is second question for name of all sensors, name in autonomous vehicle. Yes, it is. What do you mean name of sensors? LiDARs, radars, or the brand names you're asking me? Could you be more specific, Mr. Parthiv Bhatt? Could you be more specific? What are you asking? Name of all sensors. Sensors are LiDARs, radars, cameras. Those are the typical sensors. What do you mean type? Okay, let me type it out. LiDARs. So I don't have model names of them. I think for LiDARs, this company called as Velodyne, which is very popular, which is used for LiDARs. But for cameras and for radars, I don't have makes or the names of the companies which make them. Those are proprietary, and usually companies don't reveal them, if that is what you're asking. Okay. So for LiDARs, I think this company Velodyne is the most popular, and you can check that. Okay, so Velodyne is the name of the LiDAR company. That is very common, yes. This setup in Opal RT. What is Opal RT, Archana? Okay, there was many questions. Let us start with the first question first. Varsha Chaurasia. Okay, Carla simulator. Can you name some easy simulator where one can simulate AV for research purpose? I'm sorry, I don't know much about simulators. I haven't used them, so I won't be able to help you with this, Varsha. Let me come to Archana. You have discussed about FPGA. What is its use? So FPGAs can also be used to execute AI models. Okay, so you can have an AI model, a convolutional neural network model, and that model can run on an FPGA, a field programmable gate array. And it is going to run faster because it can use concurrent data paths, and that is an option. So FPGA can also execute AI models just like CPUs and GPUs. Okay. So that is the use of FPGAs. So you can basically prototype any hardware on an FPGA. You can create the Verilog VHDL code. That code will run on an FPGA, and that is used to prototype any kind of chip architecture. Okay, very good. Any other questions? Okay, so we have, okay, let's see how many questions are there. 3, 4, okay. Okay, so things, everybody is happy. And so are we done, Anukriti? Then everybody seems to have understood everything there was to learn here.
Yes, sir. Yes. Yeah.
Oh,
Yeah, I think there are no more queries.
Okay, there are no more queries. Okay.
Yeah. Thank you, sir, for the
Sure. You
lecture.
guys are more than welcome. You are very welcome, Anukriti.
Thank you, sir. Thank you so much.
Okay, so I'm going to leave now. Okay, so
Yes, sir. Yes, sir.
let
You
me
can.
turn on my camera and wave you guys goodbye. Hopefully, you did learn something from me. And yeah,
Yes, sir.
we'll
It's
get to
very,
meet again
very.
sometime. Yes, hopefully it
Yeah.
was something useful for
Hopefully.
you guys. Okay, bye-bye for now. Enjoy the rest of your evening. Okay, bye-bye. And maybe you can visit
Thank-
Kumbh. You have some time, you can go and take a dip there. Yes, Professor Singh.
Thank you, sir, for your wonderful.
Sure. Okay. Okay. Yeah. So I recommend that you visit the links I have shared with you. If you want, I can. I don't know whether you share the presentation with your delegates or not, but if you are interested, I can give you the PDF file of the presentation so that people can look at the references and the links which I discussed in the presentation. If that is
Yes,
useful,
sir.
I can email it to you maybe tomorrow or the day after tomorrow.
Yes, sir.
Okay, so I will then email it to you, and you can share it with your participants. Okay.
Okay, sir. Okay, sir.
Okay, perfect. Anything else before we end? Okay, so thank you very much. We can end now. Bye-bye for now.
Good night,
Bye-bye,
sir.
guys. All of you. Thank you. Thank you. Bye-bye.
Let's take a 5-minute break until the second speaker will come.
Anukriti,
Yes, sir. Yes, sir.
it will be started on 7:30.
Okay, sir.
Okay, after 30 minutes.
So-
Schedule will be on a time.
Okay, sir.
Okay.
Thank you. Okay. So,
After
okay, sir.
25 minutes, it will be started. Everyone should be joined with the same link.
Yeah, yes.
Okay.
Okay.
अजरे भी रहे और सारे हो सके उनकी जम के जमा के हम के साथ और खेती
कमल विरोधी अजमल के इस बयान को बीजेपी ने बांग्लादेश की घुसपैठियों से जोड़ दिया। बीजेपी ने दावा किया अब कुछ छुपा नहीं रह गया कि आम आदमी पार्टी बांग्लादेश की घुसपैठियों के लिए का चुनाव जीतने में लगी हुई है।
मैं देश और दिल्ली की जनता को बताना चाहता हूँ मौलाना बदरुल उसके